Here we are going to discuss and demonstrate how to solve a pair of simultaneous linear equations. There are different methods. You have elimination method, substitution method, you've got matrices, and you also got graphically, and you also got trial by error. And you may have other methods also. Now, the elimination method always works well. Well, all the methods work, but some methods work better than others depending on the question. So now, let's explain this carefully. All the methods work, all of them, but some work better than others depending on the question. So when you look at this question, you've got to look at the coefficients, the numbers in front of the x, and also the way the question is laid out. So because you got x under x and y under y, and the constant under the constant, this is a classic setup for either the elimination or the substitution or the matrix method. Okay, the graphical method can work there, but this is a classic setup for either elimination, substitution, or matrices. Now, a setup like this, matrices will work perfect. It will work fine. Now, elimination method will work fine also. The substitution method has a little bit of specifications for it to work better. For substitution to work good in a setup like that, one of the coefficients must be 1. There must be a 1 in front of one of the letters, meaning you do not have to see a number in front of one of the letters. Remember we said when you don't see a number, there's an invisible 1. Okay, so because we have 2 with 1 in front of them, we've got a 1 in front of the y, we've got a 1 in front of the x. So the substitution method can work very fine there. Now, matrices now is a topic in section B. So I will take that opportunity to solve this using matrices, because matrices is a topic in section B, vectors and matrices, and a question like that can be placed in section B, and they will tell you to solve by matrices, and you must solve by matrices to get your mark. So let us solve this by matrices. So the first thing now is to set up a matrix equation by using the coefficients in front of the letters and the constants. So write this down. Matrix equation. First step. So here's the matrix equation. As you can see, you've got a 2 by 2 with the coefficients. 3, here it is. 1, here it is. That's the first row. And the second row, 1 in front of the x and -2 in front of the y. Multiply by a column matrix, 2 rows and 1 column with the letters. X comes first, y comes second, from left to right. So x on top, y below, and 1 over 5, 1 above 5. As you can see, the equal sign. So you can see it's matrices, 2 by 2, a 2 by 1, 2 by 1, and the equal sign. So you have the matrix equation. The next step now is to find the inverse of the 2 by 2. Just like how I'm looking up in YouTube, how to find the inverse of 2 by 2 matrix. I want you to do that. in YouTube. You can do that in here. You can do this in Google, and you can also do this in YouTube. You have to find the inverse is 1 over the determinant times the adjoint. 1 over the determinant times the adjoint. And here you have it explained to you. And then you can also go to YouTube and find the inverse of 2 by 2. Take your, and here you see 1 over the determinant times the adjoint. And please take your pen, your pencil, your paper, and practice how to find the inverse of a 2 by 2 matrix. You can use Google and you can use YouTube. It's 1 over the determinant times the adjoint. Now, what I'm using an online calculator called Symbolab. It's free. You can just type Symbolab, and it's very, very good. And I'm going to find the inverse of my 2 by 2, inverse of 2 by 2, and here it gave me the solution. 2 over 7, 1 over 7, 1 over 7, 3, negative 3 over 7. And it explains to you step by step. There's this notation for the inverse, a negative 1 on the top right corner. The inverse of this matrix is 1 over the determinant. The determinant is negative 7 times the adjoint. You have to find out what is determinant and what is adjoint. How to find the adjoint. Here it is. You swap those two elements, those two, A come down and the D come up, and you multiply the B and the C by a negative sign. You change the sign of B and C. So as you can see, the negative 2 come up, the 3 come down, and move the ones into negative. They call that adjoint. And the determinant now is A times D minus B times C. 1 over the determinant times the adjoint. So it is preferable to have the determinant in that way. Don't multiply by the fraction yet, because it will always be a 1 over something. There is 1 over 1 is 1, but 1 over any other number, there will be a fraction. So do not multiply that 1 over that fraction yet by the matrix. So just use this as your determinant for now, with the fraction outside of it. 1 over the determinant times the adjoint. Leave it like that for now. So as you can see here, I've written down my inverse, 1 over the determinant times the adjoint. Now, the next step now is to multiply that column matrix with the constants multiplied by the inverse. The inverse times that column matrix here as the next step. So again, I'm going to use Symbolab to do that multiplication for me. I'm going to leave the constant outside there still, and I'm just going to multiply this adjoint by the matrix. Now you need to research how to multiply matrices. It's rows times column. You can use Google for that. You can use YouTube for that. Here I've typed multiplication of matrices, how to multiply matrices. Here you've got a lot of information of how to multiply matrices. Okay. If one doesn't work for you, click on the other one. Here, this one explains it nicely, how to multiply matrices. Okay, here it is. It's always rows by columns. And when you multiply matrices, you always have to add. You can also use YouTube And you get lots of videos demonstrating to you how to multiply matrices. And you know what you've got to do. You've got to take your pen, your pencil, your paper. Okay, here is a classic one, a 2 by 2 times a column matrix. Okay, because that's what our question is going to be doing. And then you follow it, you write it, you practice it. You have to do it. You have to do it with the video. You cannot just sit down and watch the video and say, well, okay, I understand. Okay, and you have several videos, thousands of videos that you can use to know how to multiply matrices. Now, as I said, I'm going to leave the 1 over the determinant out for now. It's easier to just multiply the simply pure matrix by the column matrix. Okay, you do that first. Remember, you practiced already. And here Symbol has done it for us. And it says the solution is negative 7 over 14. It gives us some steps. Okay, row by column. As you can see, negative 2 by 1 plus multiplication of matrices has a plus inside of it, plus negative 1 by 5 rows by column. Okay, and then the second row, negative 1 by 1 plus 3 by 5. And then it simplifies for us. It's negative 7 over 14. Now we are not through, because remember the constant we had left in front. Okay, so now we're going to multiply that negative 7 over 14 by the constant we had left outside. The constant was a fraction. It was 1 over negative 7 multiplied by the negative 7 over 14. Now we're going to multiply a matrix by a number. You have to multiply all the numbers in the matrix by that number. They call it scalar multiplication. Scalar in maths means a number. So 1 over negative 7 times negative 7. And 1 over negative 7 times 14. 1 over negative 7 times negative 7, that's negative 7 over 7, that will be 1. 1 over negative 7 times 14, that will be 14 over negative 7, that will be negative 2. The symbol has done it for us. And the answer is 1 over negative 2. So that means x is equal to negative 2, x is equal to 1, and y is equal to negative 2. So just to summarize, we make a matrix equation, a 2 by 2 with the coefficients, a column with the letters, and a column with the constants. We find the inverse of the 2 by 2. Then you multiply the matrix part of the inverse. Leave the fraction out still. The matrix part of the inverse multiplied to the column matrix with the constants. And the answer you get, then you multiply that answer by the fraction that was left out in the first place, and then you get the answer. X is equal to 1 in that case, and y is equal to negative 2. Now you've got to put pen to paper.